All right, we're recording Friday's first period geometry lesson on March 28th, and we are on page 408, 10-2, diagonals and angle measures. And in Braille, we're actually on 408C, and there's a quadrilateral on this page with a diagonal going from D to B. So we have a quadrilateral. We're gonna use this quadrilateral to get us started, and then we're gonna start thinking about things and come up with the next theorem on our own. It's obviously in the book, but we're gonna see how it happens through our deductive reasoning. So you have A at the top, B is at the right, kind of top right, C is all the way down at the bottom right, and D is over on the left, and then there's a diagonal going from D to B. And so what this drawing is showing is, first, what kind of figure do we have? Name your figure.
A, B, C, D, quadrilateral.
Quadrilateral. And is it regular or irregular?
I think it's irregular.
It is irregular. Yeah, none of the sides equal.
How do we know exactly?
What is the definition of a regular polygon?
Is it curved?
All sides have to equal, and all angles have to equal. Do any of these sides equal each other? Do they all equal each other? No. Do all the angles equal each other? No. This is irregular, not regular.
So
Angles and sides have to be congruent. None of the angles or sides are congruent, correct?
Yeah.
Okay. All right. So this is a quadrilateral, and when we go from D, there is one diagonal to B. That's the only way. That's the only non-consecutive pair of angles, right?
Yeah.
From D to B. And then from A to C, there's one diagonal, isn't there?
Yeah.
So there's one diagonal from each vertex. So this quadrilateral can be split into how many triangles?
Two.
Two triangles.
What do you put diagonal coming from there?
Yeah, but you only use one diagonal to split it. You're splitting it. It's not, if you go from there, you split it, you don't split it into four. I mean, you do split it into four triangles, but we got to talk about the interior angles and the sum of the interior angles. So what is the sum of the interior angles of a triangle?
180.
180. And so the sum of the interior angles of a quadrilateral is what?
360.
360, because we have those two triangles, right?
Yeah.
Sharing all those vertexes. So by drawing a diagonal or diagonals from one vertex, we figure out how many triangles that make up the polygon. And a triangle is 180 degrees. The sum of the angles is 180 degrees. That's the angle sum theorem. We can then figure out how many degrees are in our polygon. So if we make some notes, if we say, okay, we get out our Braille note or whatever, and we make some notes, and we say a quadrilateral, it's four sides, and it has one diagonal coming from the vertexes. Each vertex only has one diagonal. We could have one diagonal from A, we could have one diagonal from B, we could have one diagonal each, but we just can get one diagonal from any given vertex. We can only get one diagonal, which then splits it into two triangles, which then means it's 2 times 180 degrees, so we know the sum of the interior angles is 360. Did you follow that?
Yep.
Okay. Notice in a triangle, if you think about a triangle, is there any diagonals in a triangle? Or do you have any non-consecutive vertices in a triangle?
No.
No. So you don't have any diagonals. Well, that would make sense. Then, okay, 0 diagonals means that I have one triangle, and 1 times 180 is 180. So let's think about a 5-sided figure. So I'm gonna help you locate one in your book so that you can reference it. There is a 5-sided figure. There's an 8 here. 1, 2. That might get a little messy. I'm gonna go backwards. All right, 5-sided figure on page 307L. There's a pentagon. So turn to 307L.
Do you mean 407?
I'm sorry. Thank you, Bryant. 407, 407L. And at the very top, there's a pentagon. Can you find it? 407L. Go backwards.
Oh.
I'm trying to help you find different figures to like think about what's going on.
That's 407. Oh.
Alright. Alright, you find your pentagon, 407.
I found it.
Okay, so take like the top vertex, and how many diagonals would we have from that vertex? How many non-consecutive vertices do we have? We have one all the way down to the bottom left, and we want to have one all the way down to the bottom right. So at any given vertex, there's two potential diagonals, correct?
You mean like from there to here.
And then, so from the top vertex, you go from there to there, and there to there, okay? Because everything else is a consecutive, isn't it? From there to there is consecutive. You can't go there. You have to go to angles opposite for the diagonal, okay? So you have two, so in a quadrilateral, in a triangle, we had 0. We had 3 sides and 0, right? In a quadrilateral, we have 4 sides and we have 1 diagonal, which creates 2 triangles, which means we have 2 times 180, which is 360, isn't it? In a pentagon, a 5-sided figure, we have 2 diagonals, which creates how many triangles? 3 triangles.
So, like if we go from there to there, 1.
1.
And if we go from
No, don't cross over. You can't cross over. If you start at that vertex, you go from there to there, then you have to go back to that vertex and go from there to there. You don't cross over.
there,
So you create 1 triangle, 2 triangles, 3 triangles, right? We create 3 triangles. If you have 2 diagonals and 5 sides, you create 3 triangles. So 3 triangles times 180, how much is that? What is 3 times 180?
Isn't that more
3
than
times 180 is like
Four-
420.
540.
Oh, 540, that's right.
All right. So that is, so then what if we have a 6-sided figure? So let's see if I can find a 6-sided figure. Oh, that's 8. Oh, back up 2 pages. Back up 2 pages to J407. At the bottom, there's a hexagon.
So, kind of you have that.
So how many diagonals would you get from any one vertex in a hexagon?
Oh, this one you're talking about?
1,
Is that at the bottom of the
2,
page?
3. There's 3 non-consecutive angles to every vertex, isn't there? So we get 3, so how many triangles do we get? 3 diagonals creates
4.
4 triangles, yes. So we would have 4 times 180, wouldn't we? In our 6-sided figure. 4 times 180, 400, 320, 720. So a 6-sided figure has 720 degrees on the inside. So are you seeing a pattern? A 4-sided figure has 2 triangles. A 5-sided figure has 3 triangles. A 6-sided figure has 4 triangles. What's a 7-sided figure going to have?
5.
Yeah. And so a 7-sided figure has 5 triangles. So how many degrees is it going to have? 900. An 8-sided figure has how many triangles?
6.
6. And 6 times 180 is 1,080. Yeah, 1,080. So are you seeing a pattern?
Yes.
So so if it's 4-sided, we have 2 triangles. If it's 5-sided, we have 3 triangles. If it's 6-sided, we have 4 triangles. If it's 7-sided, we have 5 triangles. If it's 8-sided, we have 6 triangles. If it's 9 triangles, we have 7. What's the difference between the sides and the triangles? What does difference mean? What is the difference between the sides and the number of triangles? A 4-sided figure has 2 triangles. A 5-sided figure has 3 triangles. 6-sided figure has 4 triangles. What's the difference?
It's different because of what?
Mathematically, what does difference mean? Grr. Subtract. What is the difference between the number of sides and the number of triangles? 4 sides have 2 triangles.
Yeah.
5 sides have 3 triangles. 6 sides have 4 triangles. What's the difference between the number of sides and the triangles?
But you're not subtracting.
Yes, you are. What is the difference? Answer the question. Grr. A 6-sided figure has 4 triangles. What is the difference between the number of sides and the number of triangles? Somebody please do 6 minus 4.
2.
2. Oh my goodness gracious. Holy
Oh
mackerel.
my gosh.
Come on.
You
Turn those
didn't
geometry
give
brains
enough
on.
details
Are you
to be-
serious? I said, what is the difference between the number of sides and the number of triangles?
She's talking about the hexagon.
4 sides has 2 triangles. 5 sides has 3 triangles. 6 sides has 4 triangles. 7 sides has 5 triangles. What is the difference every time?
2,
Say it. 2. So 10 sides has how many triangles?
8,
8. 20 sides has how many triangles?
Holy cow.
20 minus 2?
That's
18. A 100-sided figure would have how many triangles?
88 or 98.
98. Always. The number of sides minus 2 gives you the number of triangles. Why is it important that we want to know the number of triangles?
Because
Then what can we figure out?
um,
What were we figuring out? How many degrees are in a triangle?
180.
180. So if we know the number of triangles in our polygon, can we
can
figure
find
out the
how
number
many
of
degrees.
how many degrees are in the polygon?
Yes.
So if we have an 8-sided figure, how many degrees are inside of it? How would you figure that out?
You would
Multiply what?
180 by the amount of triangles.
So if it's an 8-sided figure, how many triangles? 6.
6. So
6 times
180.
180. What's 6 times 100?
600.
What's 6 times 80?
That's my question.
What's 6 times 8?
50. No. 48.
48. 480. What's $600 and $480?
That's a lot of money. That's 7, 8, 9, 10, 1080.
1080.
1080.
Yeah. 1080 degrees in an 8-sided figure.
Yeah.
If it was a regular octagon, we could take 1080 and divide it by 8, and we would get the measurement of every angle in that octagon.
Wow.
1080 divided by 8. What is that? 1080 divided by 8. Come on, people, participate. Click it on your calculator, do whatever.
1080 divided by 130.
135. That's if it's a regular octagon. So if you're told it's a regular octagon, you know all the angles are equal.
Yeah.
So you're able to divide 1080 by 8, and you'd be able to say, if that was an 8-sided figure. What if it was 7 sides? How many degrees would be on the interior? So what do you got to do first? What do you got to do first? How many triangles do you have? 7-sided figure. 5 triangles. 5 times what?
180,
Gives you
900.
900. Good. If it was a regular heptagon, what would each angle be?
Divided by 7.
Mm-hmm.
And that's 128.
128-ish. Yeah. Okay. That's if it's regular. If it's not regular, you just, they're just going to add up. They're going to be all different sizes, and they just add up to 900 regardless.
Can you have a triangle with all obtuse angles?
No. Can you? Can you add up anything? Can you add up obtuse anything over 90 and get 180?
Oh, never mind. That
No.
was a heptagon.
Heptagon.
I was thinking about it because it was like 125. I'm like, wait, you can't do that with a triangle.
That's a heptagon, right?
Mhm.
You're figuring out based on your triangles. So if you have a dodecagon, which is a 12-sided figure, dodecagon would be a 12-sided figure.
Do we have
So how much would be the sum of the interior angles? 12 sides.
8 times 10, I believe.
How many triangles do you have in a 12-sided figure? 10. What do you multiply it by?
I'll multiply it by
10 times 180?
1800.
Yes, Brian, 1800.
There you go.
And if it's a dodecagon and it's a regular dodecagon, then you would divide 1800 by 12.
And that is 150.
150 each angle. If it's regular. If it's not regular, they're just going to add up. All right? So what we just did was theorem 10-1. If we turn all the way to page 409 straight up, it says in the activity, we just did an activity. I just forced you through an activity where we thought about 4-sided figures, 5-sided figures. We figured out the pattern. We did deductive reasoning, right? We saw we had a number of sides and a number of triangles, and every time the difference is 2, isn't it? Yeah. We used that mathematical sequencing, like what's the next 3 numbers, right? What's the pattern? That's what mathematics is about, is studying the numbers and what's happening and thinking about what's going on here, and is there a pattern, and can I make a deduction and come up with a theorem? And so here's the theorem that we came up with for that, because in this activity you discovered that 2 triangles are formed in a quadrilateral when the diagonal is drawn from one vertex. So the sum of the measures of the interior angles is 2 times 180 or 360. You extended the pattern to cover other convex polygons and found the sum of interior angles of a polygon with n sides. The results are stated in the following theorem. So turn the page. So it says theorem 10-1. If a convex polygon, it only works for convex.
What page are we doing?
409A. If a convex polygon has n sides, then the sum of the measures of the interior angles is open paren n minus 2 close paren times 180. That's what you just did, right? Yep. You took the number of sides, subtracted 2, and then multiplied it times 180. That's theorem 10-1. It's on A409.
How come I don't have a page?
You do.
Maybe you're missing a page.
Holy cow. That's one.
It's right there. It's just it's out of order, isn't it? Is that it?
I have mine right here.
Why this one is blank?
I don't know. It's out of order.
It's kind of cold in here.
All right. So turn 2 pages, Abby. I think you got to go 2 pages now. It's B409. All right. There is a figure at the top. It's got some texture in it, but it's simulating a landscaping border. Okay, what kind of polygon is this?
2, 3, 4, 5, 6. It's a hexagon.
It is a hexagon, and it looks like it's probably a regular hexagon. They look very similar. They didn't give us tick marks, but
it's pretty small though.
Yeah. Excuse me. So it says in writing on the previous page, landscapers often need to know interior angle measures of polygons in order to correctly cut wooden borders for garden beds. The border at the right is a regular hexagon. Find the sum of the measures of the interior angles. So we have how many sides on a hexagon?
6.
6. So what's going to be the sum of the measures?
4
times 180.
4 times 180, okay, because you go 6 minus 2 because you have 4 triangles, right? 4 times 180?
720.
720. Now, the next question in question 2, example 2 asks, find the measure of one of the interior angles. So you're told that it's a regular hexagon. So all the interior angles are going to have the same measure. So what do we do with that 720?
Divide it by 6.
Divide it by 6. 6
And we have
vertexes.
120 degrees.
120 each. Yep. Good. All right. So turn a couple pages. You have another figure. We are on D 409. All right. We have H at the very top left, and then go clockwise to I, and then to J, and then down to K, and then down to L, back over to M, and up to N, and back up, straight up to O, and then back to H. Can you make your way all the way around that?
Mm-hmm.
How many vertexes do you have?
8.
8. So how many sides are you going to have?
8.
8. So what's this called?
Octagon.
Octagon. What's the sum of the measures of the and they're told refer to the regular polygon, so you're also told it's regular. What are the sum of the measures of the interior angles of an octagon?
Like
6 times 180.
6 times.
1080.
Good, 1080, Bryant. And what's the measure of one interior angle if it's a regular polygon?
135.
135. What did you do, Jess?
I divided 1080 by 8.
Good, 1080 by 8. All right? So you got that down? You can take any side of figure. You don't even need the drawing. If you're told it's a heptagon, what is the sum of the interior measures? You go, oh, hept is 7. 7 minus 2 is 5. 5 times 180 is 900. Done. If it's a regular heptagon, you get to do the division. You divide 900 and get 128.5-ish. Okay? So if it's not a regular, though, don't divide, because regular just means all the angles are the same. Right? All right, turn the page. We're going to discuss something else. We're going to deduce theorem 10-2, which should make sense if you turn the page, Gabby. This should make sense if you employ your memory about angles and linear pairs.
Is it on A410?
It's on A410, yes.
I don't see anything.
Plug in from many, many chapters ago, linear pairs. And what is a linear pair? 180. It's an angle. It's two angles that form a line that equal 180, don't they? So this figure has 1, 2, 3, 4, 5, 6 vertexes. It's irregular. Six-sided figure. What do we call six-sided figures? Hexagons. From each vertex, they've extended it with a ray and an arrowhead to show that any line segment can be extended into infinity. And they tell you the exterior angle measurement. So the top left one is 68 degrees. The very top one, kind of top right-ish, they've extended that side, and that exterior angle is 62 degrees. Now, and then they extended the next angle on the right-hand side down, and that interior angle they've labeled 56 degrees. You see that?
Yep.
And then you go down to the very bottom right, and they've extended that side, and that interior angle is 54 degrees.
Mm-hmm.
Exterior. And then they extend the very, very bottom angle, and that exterior angle is 58 degrees. And then they extend the angle on the right, and that exterior angle is 62 degrees, right? Did we get it all?
Mm-hmm.
Okay.
Mm-hmm.
So, knowing all those exterior angles, can we find all the interior angles?
Are the interior and exterior supplementary?
They're supplementary because what kind of angles are they to each other? Linear pairs. So let's do the 68. You want to do the very top one again, top left?
180 minus 68.
180 minus 68.
The interior would be 112.
112, okay. The next one, the very top one, the exterior is 62. What's the interior?
112. Wait,
62?
no, that's not right. I was doing minus.
118.
118,
There
good.
we go.
The next angle, the exterior is 56. What would be the interior?
124.
124. Good. The next angle down is 54. What would be the interior?
146.
126. The very bottom one, the exterior angle, is 58. What would be the interior?
122.
122. And then the one all the way to the left is another 62-degree angle, so that interior is 118. All right. It's a six-sided figure, so what should be the sum of the interior angles? Without even knowing these measurements, what should the sum of the interior angles be of a hexagon?
720.
720. 6 minus 2 is 4. 4 times 180 is 720. So if we add up all of these, should we get 720?
Mm-hmm.
Hope so. Let's try. Ready, Jess?
Yeah.
You're fast with this. 112 plus 118 plus 124 plus 126 plus 122 plus 118.
720.
720. Bingo. All right, great. Now, let's add up all the exterior angles and see what we get. 68, 62, 56, 54, 58, 62.
360.
360. Interesting.
Outside is 360.
360.
Inside is
Let's think about a rectangle. What are interior angles of a rectangle? What is each angle?
They're all 90.
They're all 90. So what would be the exterior?
Oh. 90.
90. And if we have 4 of them all the way around, they add up to what?
360 times. No, 180. It adds to 360.
360. Interesting. What if we had an equilateral triangle? What are all the measures of the angles on the inside?
An equilateral triangle.
Equilateral.
They would all be,
They each be
each should be 60.
60. So what would be the exterior angle?
60. No, wait.
Exterior?
Exterior.
What's its
Oh my
linear
gosh.
pair? What's the linear
One.
pair to 1 to 60?
That would be 120.
120. And there's 3 of them.
Yeah.
How much would it be total?
360.
360. Huh. Did we just deduce something?
Yeah.
The exterior angles of any polygon always add up to what?
360.
360. Because if you start on the outside of the polygon and go all the way around it, what basically have you created?
A circle.
A circle. And how many degrees are in a circle?
360.
360. Welcome to geometry, everyone. It's all related, isn't it?
Yeah.
So the sum of the exterior angles is always 360. We just deduced that. Guess what we just did? We just did theorem 10-2 on the next page.
And we didn't even
started.
Well, no, not next page. Couple pages. Hold on. Where
found
is,
it.
Did you find it? What page?
C410.
C410. Theorem 10-2.
Exterior angles on each vertex is 360.
In any convex polygon, the sum of the measures of the exterior angles, 1 at each vertex, is 360. Always, always, always. So that's pretty cool.
Yeah.
So if you know you can use that to figure things out. You can use your formula now for the. So if it's a dodecagon, you figured out it has 10 triangles. It has 1800 degrees on the inside. What does it always have on the outside? 360. If you're told one of the exterior angles of a regular dodecagon is 20 degrees, then you would know that the interior is 180, right?
Yeah.
And then you have 10 of them. That should be 1800 degrees, right?
Yeah.
And 20 times, oops, did I do that right? No, that would be 160. I'm sorry. That would not be a regular dodecagon. Yeah. 12 sides. 12 sides. We're on the right track. My brain just went all over the place. All right. So yes, question.
Is there such thing as a two-sided figure?
Can you close 2 sides?
Oval.
An oval, but that's not a polygon. That is a shape,
Uh-huh.
but it's not a polygon. And technically, when you break up an oval and you stretch out the piece, it's just one line, isn't it? So it's not
Yeah.
2 sides.
Oh, okay.
Yeah.
So it's a zero-sided figure.
Yeah,
Like a circle.
or it's one a one-sided figure would be bring it together and it becomes,
A
it's not a
line.
side anymore. You bring a line together in an arc and it becomes a circle or an oval or a blob, right? Okay.
Oh.
So you can't have a two sides can't close, can they? No. All right.
They would end up making more sides.
So it says find the measure of the, in example 3, it says find the measure
On 11,
on
through 4,
C410. It says you can use the theorem 10-2 to find the measure of the exterior angle of a regular polygon. So find the measure of one exterior angle of a regular heptagon. So heptagon is how many sides? Hept.
It's 7.
7. So first we got to figure out the sum of our interior angles on a 7-sided figure, correct?
Yeah.
All right, what is that?
5 times 1.
5 times 180? Mm-hmm.
My